question. You know what's funny? Because all the funding, like half of the funding that goes to comes from people who shoot birds. Because they're like,
Really?
if we keep shooting birds, there's gonna be no birds left after a while. So what if we paid people to stop?
Hello there. All right. I've seen some people have already figured out how to use the chat. We'll start off today's live stream with an icebreaker. And since today is Easter, it's what is your favorite Easter egg, literal or figurative? And so you can put like a literal Easter egg or like one of these game Easter eggs. This is the Konami code, for example. Yes. And you can do this by sending it to Chat Relay. Leo, can you explain to them how to use Chat Relay?
Yeah, and I'm also working on getting the chat relay to appear, but uh let's see. Oh yeah, here it is. You can
Oh, yeah.
message the chat relay in Zoom chat and then it relays it down to my screen and Joe's.
Yeah.
So, yeah, keep that in mind. That's the
Yeah.
only way for it to appear down here.
Yeah. In like the Zoom chat function, send a direct message to Chat Relay, who is a co-host. Oh, I see people are saying literal or figurative. You can also,
Mm.
yes. Oh, I see someone also said chocolate. Ah, that's a good one. Yes. Personally, I like the chocolate ones. Yes. Yeah. Feel free to just put like you can put like chocolate, or you can put like a video game Easter egg in the chat. Yeah, any are fine. Ooh, I see. Grata says that their favorite is the ones that are pastel colored with candy inside. Those are tasty. Yes. And of course, I'm sure you might be wondering who we are. Um, Leo is a high school junior from Seattle, Washington State. He's achieved AMC DHR in 7th grade and qualified for Amy twice. He placed second at UW Math Hour Olympiad twice. He coaches and plays frisbee. He's the captain of his school's quiz bowl team, and he likes coding and folding modular origami. He has a website at 27trees.com if you're interested in checking it out. His new game is duet typing, and he recommends it if you have patience for bugs. Yeah. So everyone give it up for Leo.
Hello. Oh, and you just heard from Joe, who is a junior from Maryland and has been doing competitive math since elementary school. He's qualified for Amy 3 times and enjoys competing in both math and physics Olympiads. I think there's one coming up soon.
Oh, yeah.
He is also the tournament chair for his Mu Alpha Theta chapter and the captain of his school's math team. Outside of this, he likes to play varsity tennis, the cello, and turn-based strategy games, and build fun contraptions.
Yes. Thank you for introducing me, Leo. And I see a
Thank you
lot
for
of people.
introducing me.
Yes, likewise. And yes, I see many people have put there in the chat. But just a reminder to everyone who's just trickling in, you have to send a message in Zoom chat directly to Chat Relay, who should be a co-host, and then your message will appear here. Because it's quite difficult for us to check the Zoom chat while we are doing the live solve.
Yeah. And if you send your message to Chat Relay, it appears on this screen and will be immortalized forever on YouTube.
Yes. Do you mind explaining the Easter egg on your screen, Leo? Oh,
Yes.
Ooh, hi guys. I heard something exciting. What are you guys up to? You guys already started the icebreaker, or are you?
oh
Yes.
yes, we've already started.
Oh, okay, okay. Is Mahmoud here as well, the Arkansas State Director?
Yes, sir.
Okay. Is it all right if I interrupt your icebreaker temporarily just to introduce Mahmoud and then continue on?
Yeah, that's all right.
Okay, sounds good. You guys are awesome. Okay, well, I also want to say hello. Hi, I'm Po-Shen. I'm sorry I can't be in this right now, but that's because I'm giving talks in Los Angeles this weekend. But you already can see you guys are in really good hands. Our instructors are fantastic, and we also have a special guest who I'll say a little bit to introduce, and then he'll hand it back to our instructors to continue on to have a great fun today. So Mahmoud is here. He's the Arkansas State Director for Math Kangaroo, and he has the real experience in schools too. He's a school administrator. He has Math 6 to 12 teaching certificate, and he also has a gifted and talented K-12 certificate. He's been teaching and tutoring math at all levels for over 14 years, from elementary to middle school math, pre-algebra, all kinds of different math classes, standardized test preparation, gifted education, and he's coached students in competitions from Math Kangaroo to MathCon and MathCons and all of these. And his teaching approach, he wants to make sure people really understand. So he makes a lot of similar problems whenever he's teaching classes. But we're happy to have him here representing Math Kangaroo today. And I'll pass it over to him, and I'll have to drop off because I'm giving talks today in Los Angeles.
Thanks so much, guys. So yeah, as you already know, my name is Mahmoud. So I would like to give you some update about Met Kangaroo. First of all, I would like to congratulate all of those participants from 2016 year this year. So test papers are going to be available starting April 1st, which is already available, guys. You can just contact your manager. Competition results is going to be available on May 1st. So we have only 25 days left. We are all excited. So winner list will be posted on our Metcon website on June 1st. Team, we also have something new coming up, team competition, guys. And the team competition registration is going to start in June, and the event is going to take place in November. So also individual competition, which is for 2027 for the next year, it's going to be open on September 15. We kind of recommend you to register early. And if you would like, or if you haven't done already, you can just sign up for our MedKangaroo newsletter to stay updated for all of those cool news. So it's medkangaroo.org/nks/newsletter/. Any questions, you can reach out to info@medkangaroo.org. So, guys, it's Sunday and it's Easter. Yes, I mean, think about that. Many of your friends, classmates, they are doing, most likely they are outside hanging with the friends, their family members. But you are here, guys. I cannot say enough how important it is. John Maxwell. I bet you don't know him, but anyway, he is one of the famous person who's a leader who dedicated his life for the leading people and rising leaders. And he says a leader is a person who advocates for others. I mean, kind of add some value to others. And this is what you are doing here, guys. You are learning math, not just learning math, you are learning how to solve problems. I'm going to talk about solving math problems for sake. You are learning how to solve, real world problems. You are solving how to, get rid of some of the conflicts. I mean, because think about any of the problems, you are just keep thinking, improving your critical thinking abilities. It's huge, guys. Okay, I know you don't know much about John Maxwell. Maybe some of you said, Mom, who is John Maxwell? It's fine. What about Mr. Beast? You all know Mr. Beast, yes? Yeah, you know. So he says you are crazy until you are successful. Then you are a genius. All right, friends. Until I am going to see you next time. Bye, genius friends. Take care.
All right. Thank you so much, Mahmoud, for your words. And I agree. Y'all are geniuses. Yes. Y'all will be geniuses. And, on the path to genius is learning, as you said. And I think it might be time to do some learning. What do you think, Leo?
Sounds like a good plan to me. All right, will you read the first problem?
All right. First problem. Ooh, this is a long one. Tom writes all the numbers from 1 to 20 in a row and obtains the 31-digit number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you can read the rest of the numbers. I don't have enough. My mouth is going to dry out if I read all that. Then he deletes 24 of the 31 digits in such a way that the remaining number is large as possible. What number does he get? An interesting problem, Leo.
Yeah, it's a lot of digits. That might be more numbers than I've seen in my math homework this week.
That's true. Yeah. Let's see. Where do you think we should start with this?
Well, I think it's good to start with the first digit. All the answer choices, and this was my instinct as well, start with a 9. I think it's pretty obvious we should get rid of the first bunch of digits because the first digit's the most important because it contributes the most to the end sum. So we want to have 9 as our first digit. Do you agree with that?
Yeah, I agree with that. And since we're always deleting, how many of this is deleting 24 digits, that means our remaining number will always have 31 minus 24 digits left, which is 7. And so we're really picking 7 digits out of these in order to get the biggest possible number. Where do you think we should get the next biggest number, Leo? I mean,
Well,
I see a 9 all the way back here.
Yeah, I was really eyeing that 9. It looks really enticing. But the thing is, I think we have to keep them in order because we can't just pick our favorite digits. We have to also care about the order. So this 9 all the way back here it's so far to the end. So if we got rid of everything before it to make it the second digit, like all of these ones, then we'd be left with only a 4-digit number. So I don't think that works. Therefore, I want to get rid of 9 as an option. Do you think that's fair?
Yeah, I think that's reasonable. If we were to choose the second 9, then, well, we wouldn't have enough digits to make a 7-digit number. Let's see. Well, we still want the second digit to be as big as possible. So, I mean, the next largest digit is 8. So, what if we tried that one, Leo?
Yeah, I think the next 8 is like here. But it still seems like it's too far into the number. So we'd have 9819920, and that's only 6 digits. So that's not going to work for us either. So I want to eliminate that. I think the next one would be 7. Can you find a 7?
Yeah, I think I can find a 7 right here as the 7 in the 17. So let's see. Would that one work? Well, let's see. The number of digits after the 7, there's 6 digits after it. So we could just take the 7, delete all these in the middle, and still have digits from over here. So we could just look at the answer choices now and say that only one of them starts with 97. But I think, Leo, do you want to go through the rest of the numbers, the rest of the digits too?
Yeah, let's just check our work, because I think it's C, but I want to make sure. I think, as some people are saying in chat, I will crash out if it's not C. Anyway, we can get rid of all of these before the 7, and also this 1, because the next most important digit is the 3rd digit from the left, and we want to put as big a number there as we can. So putting the 8 there is the most important thing we can do. So I have 9781920. Is that the right answer?
Yeah, it looks like it's right here. It's C. Yes. Oh, yes. A lot of people are saying it's C. And, if teaching live solves has taught me anything, is that the chat is always right. You want to do the honors of looking at the solution, Leo?
Yes. All right, and go. All right. Awesome. It's C.
All right. Well, that's a pretty good solve. On to the next problem. Ooh. There's a lot of pictures. Would you like to do the honors this time, Leo? Or would you like... Ooh, Leo's moving it.
I'll read this one, but I'm almost certain that I have seen this problem before, because I did the Math Kangaroo when I was younger, and I believe I have a magnet version of this on my washing machine. Just random facts. So anyway, I'll read this one out. There is a picture of a kangaroo in the first triangle. A side shared by any 2 triangles acts as a mirror. The first 2 reflections are shown. What does the reflection look like in the shaded triangle? I better not get this one wrong.
Oh, yeah. Well, these are a lot of triangles. I think we might benefit from going step by step in this problem. What do you think, Leo?
Yeah, that sounds good to me.
Yeah. Let's start with this 4th triangle right here. Well, let's see. Because it reflects perfectly across, I'm gonna do a crude drawing of the kangaroo. The tail should be over here, because it's like this. The feet should be over here, and then the head should be like this. This is the body. Body is not a rectangle, but yes. This is about the best artistically I can do. Let me see if I can make the body a little more accurate. These are the ears. Yeah. Then you've got the tail. Oh, you know what? I'm here to teach math, not art. But yes. Let's see. Oh yes, Leo's drawing is much better. Yes, look at his screen instead. So, where should we go for the next triangle?
Well, I think we should just reflect it over a second time.
Yes. These are quite difficult to draw.
Yeah. Huh.
Hold on. Let me... Well, the tail is
Something like
always-
this, maybe?
Oh yes. Oh, your drawings is so. I think I'm just gonna direct everyone to look at Leo's screen now on. As you can see, his drawings resemble kangaroos, while I don't even think you can tell this is an animal. Yes.
I think it looks like a kangaroo. I think it helps that mine is red. That makes it. That lets your eye do the work rather than working against you.
Good point. Good point. Would you like to do the honors for the final one?
Well, I think some has been lost in translation, but I'll try and recreate it now, or at least like reflect it. Okay.
I'm going to do my best to try to copy what Leo has drawn.
Oh, this is messed up. Okay. It's something like this. Let's see if it matches any of the options.
Yes. Well, seems to resemble option E the most.
Yeah, kinda. Uh-oh, I think something went wrong. Maybe we need a more
Yeah.
simplified drawing.
Yeah.
Or, ooh, I have another idea. We could just keep track of the head. Like, where's the head? It's on, like, I'll just make the head into a purple dot. So for those who can see my screen, that's where this head's gonna go. Oh, I think I messed it up in the first drawing. Oh, man. Huh.
Well, it might be too soon to see. Well, let's do it with just the head method. I've got this.
Okay.
Let me use not red so it's easier to see. Actually, let me put blue. Yes, we can use a more methodical way than just drawing out the whole kangaroo each time. This blue goes around to here, then it goes to here, then it goes to around here. Just eyeballing it. Well,
It's like at the top, right?
Yes, it's near the top, which does seem to be consistent with our original drawing. Do you think we should put our faith into our ideas?
I mean, I'm convinced by the head method, and yeah, I think the chat agrees as well. People are kind of spamming E's for the most part.
Yeah. Let's see. Is it E? It is! The chat gets it right once again. Yes. And now, do you think it might be time to move on to another problem, Leo?
Sure, let's do it.
Ooh, this one's a bit difficult to see on my screen, but a bar consists of 2 white cubes and 1 black cube glued together as shown in the figure. I'm going to draw a little line here to mark that these are 2 white cubes and not just one big blob. Which figure can be built from 9 such bars? Okay. Wow. This is quite an interesting problem. Let me draw the edges on each of these so it's slightly easier to see. But where do you think we should start with this problem?
I'm not really sure where to start, but I do know one that I think we can eliminate now. Okay, check this out. We've got a... I think this will work. Okay. Look at B. There's a bit of an issue with this, right? So we've got these 3... I'm putting blue dots on them, but we've got these 3 blacks across the side here, like the side middle of B. For those who can see, it means that we've got... it's kind of hard to orient this, but like across this... No, not this way. Like this...
Yes, it's going...
Maybe like this way?
Yeah.
Like kind of this direction? It's kind of hard to do on a screen, but... This is one of them. This right here is has to be... How do we do this? Do you see what I'm trying to get at here?
Yes, I understand what you're trying to say. Because all three of these squares on the right are, or I guess they're transparent on our screens, are black. That means that we must have 3 of these bars stacked next to each other to get this pattern. And if we were to do that, then this box right here would also have to be white. And clearly it is not
It's
white.
not. Yeah.
And
So it
so
means
we
it
can,
isn't B.
yes. And then, ooh, hold on. Let's see. Which other ones do you think we can eliminate in this method, Leo?
Well, oh, I see one, I think.
yeah.
I think C has something faulty with it. Do you see anything faulty with C?
Yeah. I mean, for example, this black one. Well, we can't have a black one has to have two white ones next to it. And in this direction, and this direction, we don't have two white boxes and cubes in a row. So it can't be C either. So
Yeah.
can safely eliminate this one. Now, let's take a look at D. Now, let's look at this corner. D seems to have the opposite problem of C, as in that it doesn't have not enough white. Well, I suppose it's an issue with the white blocks, because this white block needs to be next to another white blocks. All white blocks are next to at least one other white block because these two are together. And this white block here, it's all by itself. It's lonely. And so that's not possible by using these bars, meaning that D is impossible.
Mm-hmm. Okay. Well, people are saying it's A in the chat. How about we look at E to eliminate it first? Because I think it'd be more easy to show that A is the only option than E is... Like, then it's easier to show that E is impossible than A is possible, right?
Yeah.
Let's...
Well, let's see. What issues could there be with E? Do you have any ideas, Leo?
I think I see one. Check this out. So, and this is kind of complicated, but like, we've got this central, like, black one over here. And if there's a black one in the center of a face, it means that it's the end, like, going into the cube.
Yeah.
So it's not this or this. It's going into the cube.
Yes.
Like that way. Which means that this one right here is now a problem. Because for the same logic, this black right here also has to go through, but they kind of like bump into each other and they can't make it.
Yes. And since the blocks can't go inside each other, E also cannot. Ooh, I forgot to cross out B. Which leaves only A. Well, I mean, let's go through A. How would we build A? Well, let's start with the top layer. Let me draw some lines so it's easier to... Ooh, that's not black. To make it easier to see how we would build this. Well, if we take the top layer, we can just put 3 of these like this. One of them is like this, and 2 of them are flipped. For the middle layer, we could have one of them going left and another one. They're unflipped, I suppose. And we can do a similar thing with the bottom layer, with one of them going this way, and then one of them going the other way, and one of them going this way. And so A is buildable. Now, wow, a lot of people have said A. And yes, I see some people are finally relieved that we've gotten to A. I'm pretty convinced in the chat. What do you think, Leo?
Yeah, in all my days of live solves, I think with the chat helping us, I've got it wrong exactly once, and I don't think you were there. So your record's still spotless.
Oh.
Shall we take a look?
Yeah, let's take a look. Hey, it's A. Yes, intentional. Well, let's see. I think we're ready for the next problem. What do you think, Leo?
Yeah, let's take a look.
Oh, this one has a lot of words. Julia has 4 different colored pencils and wants to use some or all of them to color the map of an island divided into 4 countries as shown in the picture. If 2 countries with a common border cannot be the same color, How many ways can she color the map of the island? Ooh. How do you think we should start with this problem, Leo?
I see. There aren't there. Do we know how many colors she has at her disposal?
Oh yes,
Doesn't
I
it
think
just say,
she
like,
has
some number.
she has 4 different colored pencils. And
Oh,
so I think
okay. I missed this word. Yeah, good catch.
Yeah.
Um, I want to make a graph. You know, like graph theory graphs. What do you think?
yeah, we can do a fancy, or we could just color straight onto the country. Oh yes, with dots. That would make life easier.
I was thinking something like these ones border each other, so we can kind of simplify the diagram to just these 4,
Oh yeah.
like these 4 dots. I don't know if
yeah.
that's actually simplifying it. This is just my first thought.
Yes. Well, I mean, it does help with some visualizations, but I think I'll stick to the original diagram.
Okay.
Well, let's start by coloring one of the countries, you know? Which country do you think we should color first? How about the big one?
Yeah, let's. I feel like when coloring big things in, sometimes my hand gets tired. But if we do it first, then at least I'll be able to prepare for it. Let's do the big one first.
Yeah. We'll say we've colored this one color A. Because let's say Julia's colors are A, B, C, and D. And we have 4 choices on what to color this original country. Because, well, we haven't colored any other countries yet. And so I'm going to write this for here. How many options for coloring do you have for this country over here, Leo?
I see 3 options because it could be B, C, or D, assuming that's the colors she has. I think we could have. Yeah, there's 3 options I see. And without loss of generality, let's say it's B.
Yes. And let's see. Now that we've colored these 2 countries, let's go in a circle, shall we? Let's go and choose this country next. How many ways are there to color that one?
I think it could be C or D. So that means 2 ways.
So let's just say we've colored that one C. And now we've only got one last country to color. So it's just this one over here. How many ways can we color that one?
Well, you might be tempted to say 1, but Julia doesn't have to use all of her colors. And after all, it's not touching this B over here. So we could have this as either D or B.
Yeah. And so since we have 2 options, then we multiply it by our last 2. So there's 4 ways to color the big country. And so, ooh, it's right over my face. You can see it well if it's behind my hair, because my hair is black. There's 4 ways to color the big country. And then once you've colored it, there's 3 ways to color this country over here. And oh, wait, you should look at Leo's diagram. They're all color coded, so it's much easier to see. Yes. And now we just multiply all these numbers together. 4 times 3 is 12, times 2 is 24, times 2 is 48. And so we get our final answer of 48.
I don't think the chat got the same answer as us. People are saying C, some people are saying D, some people are saying E. Maybe we should find a second way to solve it. I have another idea how we could solve it.
Ooh.
Maybe some casework.
Oh, yeah. So we could go for a different method. How do we get us started on that method, Leo?
Sure. We could do... I see there's 2 cases here. One case is Julia uses all 4 of her colors. So that would be 4 factorial. Yeah, 4 factorial ways to do it with if we're going to use all of our colors, which equals 24. But what if we use only 3 of our colors? And the way we could do that is if one color is over here, like one color is used for this, like these 2 countries that don't touch each other, like over here and here. Do you think this is valid? I would choose Yeah. We can choose one color for that. So that'll be 4. And now we have to choose out of the 3 remaining colors, which is going to be the big country. So that's 3. And out of the 2 remaining colors, we have to choose this small country at the bottom. So that'll be 4 times 3 times 2, which is also 24. So then we add these together and we get 48.
Whoa. We've gotten the same answer from 2 different methods. Well, that seems pretty convincing. That's the beautiful thing about math. There's so many methods you can use, but if all of them are correct, you should end up at the same answer. And feel pretty convinced. What do you think, Leo?
I think yes. How about we take a look at the answer?
Yeah. Oh, would you look at that? Oh, I see the chat is also saying E. Ah, yes. The chat's come around. The chat is cooking. All right. That's pretty cool. Now, think you're ready for the next problem, Leo?
Will you do the honors?
Yes, I would like to do the honors. Ooh, this one's short to read, so it's easy on my throat. What is the time 17 hours after 5 p.m.? Well, 17 is more than 12, so there's definitely going to be some cycling through here. So how do you think we should get started, Leo?
Yeah, well, as you said, we can add 12 hours first very easily. So if we added 12 hours, it would go to 5 a.m. And we still have 5 more hours to add. And then I think we would do... So first we do 12 hours. And then we're at 5 a.m. And then we add 10... And then we add 5 more hours. And now we're at 10 a.m. Is it this simple? Or am I missing something?
I think you've just got it. This is a short and sweet problem. And I think, well, the chat certainly agrees with us. So I feel pretty convinced.
It is problem number 1. So it might be not that deep. Anyway.
Yes. Short and simple. Let's see. Let's take a look at the answer. Ooh. The chat proves itself to be correct again. W chat. W's in the chat. W people in the chat. Yes. Next problem. Would you like to do the honors this time, Leo?
Oh, yeah. The diagram shows a striped isosceles triangle and its altitude. Each stripe has the same height. What fraction of the triangle is white?
Ooh. That's a lot of color.
I see a clever way to do this.
I think I see it too.
Maybe with moving some areas around.
Yeah.
Joe, do you have an idea here?
Yeah. I mean, this red triangle right here and this white triangle right here have the exact same area. So what if we just flip them around? I mean, we just change the diagram to, this is not my best drawing, but 3, 4, 5. But what if we flipped it around so that these two both, I actually could have just drawn this on the original. These two both were white. Oh yes, look at Leo's drawing. That is much better. Yes, Leo, would you like to do the honors for the other triangles?
Yeah, I'll draw it in. I'm going to preserve the green, but I think that's just trying to throw us off.
Yes. Let me copy what Leo is doing. Yes. This one is red. This one, and switch it across using the same logic. It becomes green. This one, we can do the same thing. Well, we don't need to do the same. It's not the same. So we can switch this one over. Switch this one to the red. Then we can switch. Ooh, Leo's is already completed. Oh, yes. Leo, would you like to explain where we go from here?
Yeah, well, as we know these areas are the same, it kind of comes from the same fact. It's this isosceles triangle part. Those who know, an isosceles triangle has this length and this length equal. And Also, another cool fact is that if you draw this altitude down the middle, as they've already done, it will create two triangles with equal area, which is how we were able to send little, I guess, trapezoids from this side to this side, and also how we can conclude that these two sides are equal in area, and therefore we get the answer 1/2.
No, I trust that. I trust this method, and I trust the chat. So, let's see. Let's take a look at the answer, shall we? Would you look at that? Another W for the chat. Move on to the next problem, where the chat will probably earn more W's. Ooh. Bob folded a piece of paper twice, then cut one hole in the folded piece of paper. When he unfolded the paper, he saw the arrangement shown in the diagram. How had Bob folded his piece of paper? Ooh, I see. This is an interesting problem. Where do you think we should start with it, Leo?
My immediate thought is that, and this kind of has to do with what I'm studying right now, but this seems like symmetries, where these lines here are lines of symmetry. Because if you fold a paper, like if you fold a piece of paper, then make a hole all the way through it in one place. I don't know if I can make a hole in this very reliably, but like, okay, paper is pretty strong. But if you know there's a hole in one place, wherever it matched up with also has a hole. So then I guess we can make sure that these holes match up in one of these folding patterns. What do you think, Joe?
Yeah, I think these are some peculiar holes. And I think if we look at what line they're reflected across from, I think it looks like they're reflected across this diagonal right here. What do you think, Leo?
Yeah, that's what I thought too.
Yeah. And so, well, now we know it's either A or D. But which one is it, Leo?
Well, I think D would work in this case. And I think A, we'd have holes here and here, but also we have to reflect over this line like this. So we'd get 2 more holes here and here. And now we have 4, which is not what we want. We only want 2.
Yeah. So that means it can't be A, which, well, the only option remaining is D. And, oh, I see. Will has put in so many D's in the chat, and that seems pretty convincing. What do you think, Leo?
Yeah, I'm convinced.
Yes. Yes, ties in because the smaller triangles don't touch the hole. Let's take a look at the answer. Oh, it's another diagram. It's D. The chat was correct once again. On to the next problem. You like to do the honors?
Yeah. Yvonne has 20 euros. Each of her 4 sisters has 10 euros. How many euros does Yvonne have to give to each of her sisters so that each of the 5 girls has the same amount of money? Looks like a problem needing an equation. Just asking for us to write an equation for it. What do you think? Should we assign a variable? What equation should we write here?
Ooh. I was thinking we could find the total amount of money and then divide it by the number of girls to see how much money each girl should have. You think we should go with that method, Leo?
Yeah, that sounds like an efficient method.
Yes. Well, let's see. Yvonne has 20 euros, and each of her 4 sisters has 10. And so in total, they have 20 plus 4 times 10, which is equal to 60 euros. Where do you think we should go from here, Leo?
Wait, I think I drew the euro backwards. Hang on. It's like, how do you do a euro?
Is it like
I'm getting distracted. I think I might put the euro first.
Oh.
Like this?
Oh, yes. I think it goes through the middle. Oh,
Something
wait,
like
no. This
this?
is way too many ones. Perhaps.
Okay.
Anyways, back to math.
When we divide this by 5, this gives the number of euros each girl should have if they all have an equal number, which would be 60 divided by 5, it would be 12. So they need to have 12 each. So I'm going to add another option, F12. Shouldn't it be 12?
Well, let's see what the question is asking for. How many euros does Yvonne have to give to each of her sisters so that each of them have the same amount of money? So Yvonne is going from 20 euros to 12. So it should be 8 then, right? Or is there something wrong with that line of thinking, Leo?
Huh. Oh, I see what went wrong here. It's not just about how many she has to give away total. It's about how many she should give away to each of her sisters. And that would mean it should be 2 instead, because they have to go from 10 to 12. And that would be a jump of 2. Similarly, we also notice Yvonne is giving away 8 to 4 sisters. 8 divided by 4 is also 2, which is how we know we've done this correctly.
Yes.
I think the actual answer should be 2.
Yeah, I agree with that. I think you found the flaw in the reasoning there. So let's see. I see the chat agrees with us, and there's a lot of A's. They're all screaming. Yes, metaphorically and literally. Let's go. Let's see what the answer is. Hey, we got it again. Chat is as far as I've heard is like 30 for 30. And I think they'll go 31 for 31 with this next problem. Ooh. In the diagram, the dashed line and the black path form 7 equilateral triangles. The length of the dashed line is 20. What's the length of the black path? Ooh, I assume the black path is white here, Leo. That does seem like about right.
Oh, I suppose so. I was gonna say the black path sounds like something from a book almost, right?
Oh yeah.
It's like watch out, take this wand with you in case you encounter the black path.
Yes.
Anyway, we've got the dashed line is 20. So what do we do here?
Let's take a look at each one of these triangles. I mean, they say they're all equilateral. So let's say let's take a look at the leftmost triangle. Let's say this length is S and S for side. That means these two lengths also must be S. So for this triangle, the black path, or the white path in this case, has spent 2 S's for 1 S in the black path. And I think this pattern continues for the other triangles, Leo.
Yeah, I think that's right. So what does that mean for the answer?
Yeah. If each S for the black path for all of these triangles each S for the dotted path takes 2 S's for the black path, that means that the length of the black path is equal to twice the length of, it's going to go up my screen, length of the dotted path. And let's see, what's the length of the dotted path again, Leo?
Oh, it says it right here. It says it would be 20. So we'd have 2 times 20, which equals 40. So then I think it's 40.
Yes. I see chat saying 40 and D, and I also trust that chat never lies. Let's take a look. Ooh, another diagram. It's 40. 31 for 31. Let's see if they can go 32 for 32. Would you like to do the honors?
All right. Ria wants to write a number in each box of the diagram shown. She's already written 2 of the numbers. She wants the sum of all the numbers to equal 35. The sum of the numbers in the first 3 boxes. Hang on, I'm confused already. If she's written all... That's okay. She wants the sum of all the numbers to equal 35, the sum of the numbers in the first 3 boxes to equal 22, and the sum of the numbers in the last 3 boxes to equal 25. What is the product of the numbers she writes in the gray boxes? Oh, I understand. I thought there were 3 boxes here, but there's 5 boxes, and 2 of them are white. Okay, I got it now.
Yes. Now this is the screen on the bit paper is sometimes a bit confusing. So, where do you think we should start with this problem? I've drawn some little markers here to see like which ones are the first 3 boxes and which ones are the last 3 boxes. So
I think we can figure out this number right here that I've labeled as X. I suspect we could figure this one out right now. What do you think?
I think we could, yes. I mean, because we know that the first 3 boxes add up to 22. So I think we could use this information. How do you think we should do this, Leo?
Well, if we have 22 with 3 plus something and something, those other 2 addends have to equal 19. So these 2 together are 19. And I'll do like a... Okay, so we got the green area is 19. But, well, what other fact can we combine with this to find X?
Yeah, I think we can see that the sum of all the numbers equals 25. And so let's say this.
Or wait, 35.
Oh, yes, 35. Yes, I misspoke. Apologies. And that means that if we add up 22 for these first 3 boxes, or 3 plus 19, 22 plus x plus 4 must equal 35. And we can solve this for x. Let's see, we have 26 plus x equals 35. And that puts us at x equals 9. Did I do that right?
Yeah, I think that's right.
Yeah.
Yeah, that's right.
And I think we can find the value of this box on the left here in the same way. What do you think, Leo?
Yeah, we have very similar information that can give us all we need to know for that. We've got the sum of the numbers in the last 3 boxes is 25. So then what can we write immediately in the center one, given already 9?
Ooh, yes. Since these all add, let's call this one C for center. C plus 9 plus 4 is equal to 25. And we can just solve for C with some algebra. And we can see that C equals, what is it, 12? Yeah, it looks like 12. I trust in the heart of the cards, 12. Actually, I don't know which ones are supposed to be the gray boxes and which ones are supposed to be the non-gray boxes.
We could try both being gray and then see if either of them is an answer choice.
Yes. If boxes 1, 3, 5 are supposed to be the gray boxes, then it would give us, let's see, 3 times 12 times 4 is 144. That's
so
not
it's
an
probably
answer.
not that.
So it's boxes, they're trying to find the product of boxes 2 and 4. So,
Okay.
Yeah. I think we can use a similar method to find the value of box 2 as we used for box 3. What do you think, Leo?
Yeah, we already know that these 2 boxes here sum to 19. So since this one is 12, it means this one has to be 7. So I'll fill that in. And then we've got 7 times 9, which, if you remember your times tables, that would be 63.
Yes. Yeah. And then ooh, whoopsies. And then let's see. I got a bit ahead. But yes, the colors are inverted, so it's a little hard to tell which ones are supposed to be the gray boxes, but it's the white boxes on our screens. And so yes, it is A, as VG says in chat. And I feel pretty convinced by VG. What do you think, Leo?
Yeah, I'm already convinced it's A. Let's take a look.
Hey! Would you look at that? Let's go. I'm going to say that every time the answer is A.
All right, sounds like a deal.
All right, let's move on.
Oh, do you want to read this one?
Sure. Tycho wants to prepare a schedule for his jogging. He wants to jog exactly twice a week and on the same days every week. He never wants to jog on 2 consecutive days. How many different schedules can he prepare?
I like this problem because I think I see a good method for how we can do it.
Ooh.
Uh,
Would you care to enlighten us, Leo?
Well, sometimes the best way to start like an exercise is to start immediately. But what if we did it kind of bit by bit? Like we started by choosing the first day that he's gonna, or like choosing a day he's gonna be jogging, and then after that we can choose another one. So how many different ways could we pick a day that he's going to jog, just to start out? If he's just picking one.
I mean, there's 7 days in a week, and since he can pick any 7, because this is the first day, we have 7 options for his first day of the week to pick.
Okay. And then what can we do now to find the answer to the problem?
Yeah. Let's say he picked this day right here. Well, we know that he can't pick any of the days next to it, and so it would seem that he has 4 ways to pick.
Because he can't pick the same day itself either.
Yes. He's limited. He can't pick this day. He can't pick any of these 2, and he has 4 options left. But wait! I hear some of you saying, what if he picks this day on the very end, which he picks like, I think this is Sunday on most calendars? Well, that still eliminates 2 days, because once you've picked Sunday, you're not allowed to pick Monday over here. So if you were to pick this, then it's still the same result. And so, let's see, 7 ways times 4 ways. Well, that would give us 28, but I don't see 28 as an answer choice, Leo. What do you think?
Well,
how do we account for this?
I don't think we did anything wrong. Oh, okay. Oh, and by the way, for people who still don't understand, I got an image of a calendar. So, as Joe was saying, if you pick Sunday, then this invalidates both the day before and after it. Okay. What was the question again?
Yeah.
Oh, right. Why is it not just 28?
Yes.
It's because, what if we picked Thursday and then Sunday? Shouldn't that be considered the same as picking Sunday and then Thursday?
Yeah. I don't think it matters what order we pick them in. And so each combination that we have here is picked twice. For example, Monday, Wednesday, you can just reverse it, is equal to Wednesday, Monday. And so we'd have to divide this 7 times 4 by 2 in order to get the true number of ways. And 7 times 4 over 2 should just be 14. Which, oh yes, I see a lot of people are suggesting to divide by 2. Yes. And so I think that should lead us to answer B. Let's give it a C. Let's give it a look-see. It's B. Yes, I agree, Sunspeed and Will. All right. Let's see what's up with the next question. Ooh. Would you like to do the honors, Leo?
All right. Oh, a kangaroo problem. Finally. I've been waiting for one of these. 10 kangaroos stood in a line, as shown in the diagram. At some point, 2 kangaroos are standing side by side and facing each other, exchanged places by jumping past each other. This was repeated until no further jumps were possible. How many exchanges were made? Oh, okay. So it's like some of them face this way, some of them face this way. When they come into each other, or like when they come in right next to each other, then they switch. And they're saying how many switches are there? Is that right?
Yeah, I think so. Ooh. Well, we could count these all 1 switch by 1 switch, but I think it might be helpful to look at this kangaroo by kangaroo. Like, take this kangaroo over here. I mean, it'll hop over this one, then this one, then this one. And The only time it stops hopping is once it makes it all the way over here to this end. So let's say this kangaroo. We'll say this kangaroo contributes 3. And then once that kangaroo is done hopping, we'll have like I'll just indicate the kangaroos with arrows instead of drawing them, because drawing kangaroos, as you can see, did not go too well for me last time. Let's see, 1, 2, 3, 4, 5, 6, 7. Okay. Oh, you can't see the 7th arrow.
Oh, I was just gonna draw the arrows on top. Like I've got this arrow, this kangaroo points left. I see the 2 others that point left as well. So there's this one that points left, and this one as well. How about we figure out how many exchanges each of these will participate in?
Yeah.
So I see this one right here, like this one all the way, well, not quite on the end, like over here. It will be past 1, 2, 3, 4, 5. So I'd give that one 5. And then I'm going to get the same number for this kangaroo over here.
Yeah.
So they're both 5.
Let's see. So now that these are done, well, 3 plus 5 plus 5, that's only 13. So we must be missing something here, Leo. What could it be?
We could find out what the numbers will be for the other kangaroos, but my initial thought was just each pass will have a right and a left kangaroo, so they have to pass each other. But if we just count the right ones, that should be enough, right?
Hold on. I think there might be like a typo with this problem, because it says there's supposed to be 10 kangaroos, but we only have 8 of them here. And so there might be 2 kangaroos that got cut off on the ends, because I feel pretty confident in our methodology here. Let me see if the next one has a diagram with all of them, but I think we might have to call it quits on this one if we can't see all the kangaroos. Yeah. Ooh.
Yeah, I got 13 from the left ones and 13 from the right ones, so I'm pretty convinced the answer should have been 13.
If it's just these 8 kangaroos here, it would be 13. But I think Rat Chile or something must have stolen the last 2 kangaroos that were supposed to be here. You can see, yes, we cannot. This is the image. You can see that like it is centered on both sides. There are no more kangaroos over there that we can see.
Mm-hmm.
So
I will suspect the answer they want is 21. And with the test taking tip here, if you notice a misprint, you can guess what it should have been. So if we see like this kangaroo that should be right here, like kind of where my head is, if it's facing left, well, no one's going to believe it. No one's going to think it's not going to have any impact. So it has to be facing right, as long as we think the math kangaroo people are trying to make sense. So if it's facing right, it'll go past 1, 2, 3, 4. Oh, hang on. Yeah, so we can add 4. And then also... Oh, wait, I think I did something wrong, actually.
Ooh.
Oh. No, actually, I think it's 18. Hang on, I'm kind of bouncing around. Because we also need to have a kangaroo on the far right that's going to be facing left, unless it's just facing right and kind of hops out into the outback for kind of not passing anyone. Do you think that's right? Do you think it's probably just going to say 18 on the next slide?
Yeah, I would reckon it probably does. I mean, if this kangaroo is facing left, then we get an extra 3 plus 2 plus 2. That's 13 plus. Yeah, you know what? Let's just go for it. Let's go for 18. This question is like technically not for sure solvable with the information. So if you're confused in the chat, we are too, because we can't see all the kangaroos. But let's just give it a wager. Let's just give it a wager. Oh. It is 18. Leo's strategy paid off. Yes. He's just built different. Yes.
All
He
right.
can.
Well, yeah, this is all the problems we have for today. But notice I did not say we're done because I think there's one more agenda item for today. Isn't that right, Joe?
Yeah. I think there's a cool guy. A pretty cool guy is in this Zoom meeting. And I think, he might have some things to say. Yes.
Hi everyone. So yeah, I've been here this whole time, but y'all should have focused on Joe and Leo. But we have some pictures of me. Yeah. Shout out to Anna. She sent me these pictures of me. Dude, this live class was so fun. Wait, so I did this thing where I would like eat a cookie, and I would kind of just like you know what I'm saying? Like, and then just like take a bite out of the cookie. You know what I'm saying? Like Joe over there is laughing. Wait. Wait. But I know Joe has funnier things that he does. So yeah. Hi everyone. Yeah. No, I'm not just some random participant. So all of you that messaged me during the meeting, no, I'm not just some random participant. I mean, I think you could tell by the fact that I had, the math kangaroo problems on my screen. But I don't know. That was just a slight giveaway. But yeah. I'm gonna try to get Ling as well. Oh wait, okay. Bye everyone. I'm gonna head out now. I think I'm getting invited to a breakout room. I'll see y'all later. Peace out.
See
Bye,
y'all.
everyone.
Thank you for coming. Hope you enjoyed and learned something, perhaps. Bye.